All right, this is Advent of Code, day number 23, I think. Yeah, 23. All right, we've got about 3 minutes until puzzle unlock. I've already set up my files, so I'm basically good to go. Just waiting on the puzzle. While you're here, please do check out my employer, Honeycomb. We are linked right here on the sponsor page, and you can get a free t-shirt if you try out Honeycomb enough to quickly get a glimpse at how we're better. But let me give you a sneak peek of really how easy it is to do. So what it's going to do is it's going to take you to play.honeycomb.io, and you'll get a chance to look at our quick start. And in our quick start, basically what it'll ask you to do is to plot a count and a heat map, I think, of all of the root spans. So once you do that, and then once you, can I minimize this to a tray? Yeah. And once you draw a box around a thing, basically just draw a box like this. And as soon as you get the data in, that says, hey, which endpoint was slow? Hey, it's the export endpoint. Okay, which user was slow? I don't know, maybe let's look at a trace to figure out which user is slow. So as soon as you do this, you'll type something into the form indicating what answer you found to the question, and then we'll send you a free t-shirt. That's really how easy it is. It'll take you 5 minutes, and you might learn something cool about Honeycomb. So yeah, you know, while you're sitting around, have a few moments maybe before, during today's Advent of Code or during the next Advent of Code, go check it out. All right, so now into the main content. Good luck, VWoo. Good luck, good luck. Also, I was really amazed at how well multiple different approaches would have worked for solving yesterday. And that was kind of a fun surprise to see a puzzle that worked really well, regardless of which method you chose to solve it. A9 tweeted at me to say that they are good days. And 3 ones left. So I guess we'll find out what's on tonight. Guess we will find out. Three, 2, 1, here we go. Oh, okay. Yep. Okay. This doesn't seem so bad yet. I'm sure there's some twist coming up. Hi, Eric. Right, so in this particular situation, pretty much we can assume that, well, yeah, because we're being asked for the least energy, it wouldn't necessarily make that much sense for bugs to step into the corners. I guess that's theoretically possible. Oh, I guess it happens there. Okay. So, let's have a look at how to solve this. So what I want to do is I want to construct a passable list. And I think we can just, honestly, we can probably explore most of the possibilities. Like this does not feel like I need that giant heuristic. It should be fine. Okay, so let's start. So we're just going to have a row and column. I like that you're finding me quotable, Eric. That's excellent. All right, so we've got some chords and we've got some, let's see. What is this? This is a, what do we call these things? We call these things a iota and golang enum. Enum. That's the word I was looking for. Okay, so we're going to have something like this. So there are 4 kinds of objects. I'm just going to enumerate them. Okay, and we also know, so in addition to empty and wall, they will also never stop on the space immediately in front of, immediately outside a room. Okay. Okay, so now I've defined the 4 kinds of things. Okay, this is not just empty. We're going to call this a spare space. That's what I'm going to call it. So those are the varying cases. So is passable is actually going to be very, very variable. So let's deal with that in a moment. All right, so to parse really quickly, I'm also going to define a board, which is going to be a map of chord to contents, and it's going to return a world and a cost. Okay. So that's roughly what I think I need to do. So now let's handle parsing. Okay, so standard parsing for kind of character-like situations. That one's pretty straightforward. That one's just always going to be a wall. Okay. And we know that this starts off stuffed, so I don't need to worry about stuff that's down here initially. So now we have the final case, which is this, in which case, okay, so A, B, C, D. Over here, unless it is, and I can probably just hard code this, next 0, 1, 2, 3. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Okay. So now I should be able to really quickly just print the initial world state just to make sure I got it correctly. Yep, this one does not require use of strcon. And over here, oh, cost is not a, okay. Oh, switch V. Okay, that looks like everything's successfully parsed. So now that everything is successfully parsed, we can work on our search algorithm. So, actually, yeah, no, that's how I want to handle this. So yeah, the ending state is always going to be A, B, C, D, like this. That's important to know. All right. Oh, I can use deep equal, but I don't love it. Okay. All right, so how are we going to do this? So we are sorted when zero, one, two. This is hacky, but this will work. Admin code is sometimes not necessarily about doing the optimal thing. It's just about doing the thing that's good enough. Okay. Yeah. You know, not really loving setting this up as a map, actually. Given that I know, at least for the moment, that this is going to be a, what, essentially a, this one is 9, 10, 11, 12, 13, I think. Yeah. 13 by 5. I'm going to do it this way. All right. And let's fix these guys. Okay. I don't tend to look at other people's code when I'm doing admin of code. Sorry, Correcker. I'm just here to kind of do my own puzzles. Okay. So... see this. One thing I will do is I will take... which day was it that had the A star? I will take my code from the A star and move it here, because this potentially seems relevant and useful. So, take that and cut-paste it in. Because I have a suspicion I'm going to need it. All right. So, what moves can I possibly make? Ah, the joys of having my office in the kitchen. Okay. Alright, so how do I think about generating moves here? We can have worry that this is going to be inefficient to find the coordinates of the various puzzle pieces. So why don't we? Yeah. Okay. GM rubrics, how am I doing on this puzzle, they ask. I'm doing fine. I think I have some idea as to some of the logic that I'm going to need. I'm not yet 100% sure which pieces I'm going to need to put it together. But I think that, basically I'm going to need to perform a search over the available moves. And then, eventually I will terminate once I will terminate once I find board states that end in the desired condition. So I know, for instance, that I might want to have an A-star heuristic. I know that I might want to, yeah. That's basically how I'm thinking about this right now. So something like that. No, let's do that. World and tiles. Oh, wait, this doesn't need making anymore. This is, okay, that also does make my life easier. Okay, how do I avoid backtracking? I remembered I had to deal with something relating to backtracking in... Which other day was it? Day 15. So on day 15, how did I avoid backtracking? Was it with the heuristic or... No, I see. Right. For each neighbor, we get the proposed score. Yeah, and we only iterate if the proposed score is less than the previously known score. Okay, that's right. That's good. Okay, so I don't have to worry about whether I'm backtracking here. Great. Okay. So that's going to be a kind. Cost per move, which is just because I'm moving them one tile at a time. Cost is going to be right. CD, and this one is going to have a cost of 1,000, 100, 10, and 1. Okay. So then I can all right. So the piece can up, down, left, right. All right. This is definitely fun in that it's not like a, yes, you did write an A-star search earlier, but like this A-star search has a slightly different way of thinking about it. So actually, I could almost make this into a, let's do this. this. If something is located anywhere other than the entrance, yeah, let's just assume it's going to cost, I don't know, 1 to move around. That's fine. Because it only has to be a underestimate, or sorry, it only has to be an underestimate. It doesn't have to be perfect. Okay, so that'll work, and that's a nice, fun way of creating the lowest possible cost to compute the heuristic, which is kind of nice. Okay. The other way of solving this would be, now that I have the list of pieces, I can even get the coordinates, which would be better. How would I handle this? Oh. Great. Top space. Okay. Is it tiles or tile? Not tiles, great. You know what? I'm doing this too often. And I know that Go does a good job of inlining this. So we're going to handle this way. Where is this defined? Where did I define the consts? There we go. Maybe Go will complain at me. If so, I'll fix it. Slightly less worried about that right now. Okay, because this is an important set of definitions, this all gets moved up now to go right next to the definition of contents. Okay. Cool. similarly, this will kind of avoid this problem. So this is 3, 5, 7, and 9. Ah! There we go. Sorry about that. You get to have a look at my desktop for a moment. Okay. So we're back down here. W is a struct which the compiler would have eventually complained at me about. It technically needs to be w.tiles, but let me see whether I've made the mistake in Rails. No, I haven't now. Okay, so so if p dot c is not equal to kind dot destination columns, this is called destination column. Okay. Where was I? I was working in min cost to sort here. Got lost in my own code. Okay, then if the row is not 0, 1, 2, or 3, oh, but there's in fact, yeah. All right. All right. that'll work. That seems like a reasonable heuristic to me. Great. Now that we're done with our heuristic, that seems reasonable. Cool. Just the other way. This is what the A-star search solves. The A-star search handles traversal over unknown conditions, approximating getting towards the end. You don't have to know what the possible ways are. You can brute force it to an extent with the A-star search. That's the whole point of all of this work that I'm doing here, is to set this up correctly. Okay. Yeah, I don't. Movement cost. Okay. Oh, wait, I have to be careful here. There are going to be 8 elements in pieces, because otherwise, having this thing here, in order for just doing strict equality works. Yes, exactly. GM Rubik's is that I'm enumerating all possible moves, and also, importantly, keeping track of whether I've already been in a position and what the lowest cost was to get there. Right. So in that way, it's very, very, very similar to day 15. Yes. A fixed length array as opposed to a slice is comparable. That's why I've structured this very, very, very carefully. Right? Every single thing here is completely comparable. And I ominously said BRB to that, which I don't know how to interpret, but I'll take it. It does mean that I need to rewrite this code a little, but that's fine. Yes, I'm aware of the restriction that there are 4 spaces, the spaces just above each column where you cannot stop. My mechanism for solving that is to, if I am in one of those positions, I'm going to mandate continued movement from there. Right, so the way that I deal with that is like this. Right, there's going to be a maximum of 1 piece with forced movement, so I think that's okay. Right, this is how I solve this. Ah! Damn it. I hate the whatever operator that is that causes it to rewrap. It's heck of annoying. But yeah, something like this. So that's how I plan to do it. That way I don't have to look more than 1 ahead, and it's still fine. Actually, so in that case, I don't have to enforce the constraint of something being an exit, because that is automatically enforced elsewhere. I also don't have to enforce the condition of room, so it's just empty wall ABCD. That's now enforced here. After tiles, and do this just to make life easier. Again, that's basically word for word identical, and I could, in theory, make it better, but not going to be bothered enough to do that right now. I'll tidy it up if I get time to tidy it up afterwards. Okay, so now I've dealt with this. So this is always going to be row 1. For C is equal to 3, C is less than or equal to 9, C plus equals 2. If W tiles RC is not equal to empty, then we return a chord of RC. Otherwise, we return nil, because I couldn't create a piece with forced movement. I couldn't create two pieces with forced movement, because once I get one into forced movement, I have to move it out. I can't just leave it there. Okay, so now I don't have to special case this in allowed movements. This is just simply if and because this is all very well bounded, I can basically, I'm never going to run off the edge because the tiles can never leave the board. And if they do, I do want to immediately bail, which is fine. Okay, so w.tiles index R index C. Okay. So I want to do this effectively as a for loop, but I can just do this the lazy way as well. because there are really only 4 possibilities. R minus 1. R minus 1. R plus 1. R plus 1. And C minus 1. C minus 1. And C plus 1. And C plus 1. Never step in the space immediately outside the room. They'll never move from the hallway into a room unless that room is their destination. Oh, and that room contains no pods, which do not also have their room as their own destination. Okay. Oh, once the amphipod stops moving in the hallway, it will stay in that spot until it can move in a room. I missed that constraint. Interesting. So I guess that means that if you start moving one and then you decide you need to move it further later on, you can't. I'm going to not worry about this for now. Guess the way I can handle this is... This means that it's an important piece of info what the currently moving amphipod is, because otherwise that could be a problem. All right, I don't love it, but I'll take it. All right, I'm willing to do this. So I guess that is an important rule. Wait, but if I'm in the hallway... Okay, I'm actually... So we're going to leave that constraint out for now. Okay. All right, so now I have to deal with the constraint of... cannot move into a column it does not belong in. All right, so this is the only circumstance in which we could accidentally missort an arthropod is the case where we are incrementing row but not column. Lock the path for... Okay. Right, so oh, wait. Right. Alright, this will make life easier. Destination column. So if there are, or the cases that can happen here. I think that covers it. So we're checking the tile below and making sure that's empty. If it is empty, oh, there's okay. So 2 below. Okay. Yep. Okay. That looks good to me. All right. So now I think we're ready to follow this. All right, so let's change risk map to score cost. Why did I call this R? I don't remember why I called it R. I'm just going to change this to M across the board just to make my life easier. Okay. So over here, we're going to define what a cost map is, which is going to be a map from world to int. Don't remember why I made that a pointer. Oh, because, okay, I see what I did here. Alright, so now I think I just... In fact, I don't know why. Why did I on day 15 create the initial risk map? Oh, right, so that was just the cost to move from one to the other is why, but I don't need that anymore. Okay, that's what I thought. Okay, so we just need a start. Fair enough. I'm really curious what part B is going to be. I guess I can kind of spoiler myself a little bit by seeing how many people have solved A but not B. Oh, wow. There are a lot of people who are still working on part B. Holy goodness. Okay. Well, that's exciting. That's fine. Okay, there's no longer the idea of dest. So I'm going to take that away. And I created a heap queue over here. Okay, so we're going to take this code here, and we're going to extract it, the relevant bits. Aha! So here is the first time when we might, just might, need generics. Because I really don't want to rewrite this heap heap queue code is a thing. So that's what I'm thinking about now. I'm going to cut paste it for now, and then I'm going to learn how to do this later. I think that's probably lower risk. So I'm just going to swipe. Going to swipe all of this. Okay. There are a number of worlds I need to explore. And there will also be worlds, and then finally here, this is a cost. And this is also a, wait, what was this? Say, a story map. Oh, okay, that could have been defined the same way. All right, learn something as we go along. All right, at the top, we're going to need to import container heap in order to make this remotely efficient. So that still is fine. It's fine. Really? Oh, I see. Okay. And this, instead of being chord, takes world. Okay. That should do it. Line 140 is wrong. Oh, that needs a range. Line 209 is wrong. Oh, that's just me failing to take off the closing braces. Shame on me. Line 241. H dot positions, comma H dot positions. I don't see what I did wrong here. Oh, I see. Positions, and then parentheses elms. Here. Okay. All right, that looks a little bit more ruly. Oh, I think I understand how to do the hall pass constraint. I think you would have to have a mechanism of checking whether the path is clear. And if the path is clear, one of the possible moves is to change who the hall pass belongs to. Okay. I'll buy that. Okay. I'm just going to write this down for now because I'm not convinced that I need it right now. But way to handle this is to only allow changing the hall pass. Null the hall pass holder to 0. Nobody. The last hall pass holder is no longer in the hall. Okay. Great. I don't need to keep track of the history anymore. Yeah. Because I don't need to track the route that I took to get here. We can just, if current dot min cost to sort is 0, yeah, G score index current. I'll do it. Okay. So now this is making a heap queue out of, what does the heap queue take? The heap queue takes a list of worlds. Okay, that's fine. So that's going to be that. That's okay. F score and make cost map. Yep, that's fine. Okay. And that gets coerced to a world. That's not neighbors, that's generate moves. We don't need to keep track of, where did R come from here? Oh, yeah, that's fine. So this is current generate moves, except for this has a Generate the moves. This is so much easier having already written this A-star search. Otherwise, it might be a little annoying. Okay. So cost index I, that's fine. And it's going to be G-score of current plus, yep. G-score of after. We don't need history. Is new a keyword in Golang? I'm not going to bet on it. Okay. This might just work. Let's try it and see what it says. Oh dear. Okay. Line 132. Oh. Right. Okay. Line 146 is wrong. Oh, yep, that's correct. Okay. Oh. Sorry. Right. Heuristic. Heuristic is actually now being called min cost to sort. All right, getting to the bottom. That's costs index I, and we're missing a return at line 302. Oh, and this is just going to be whoa, okay. Well, that's exciting. Progress. Oh, right, because we didn't update the pieces list. Righto. After pieces index I equals dest. Okay, and now we just need to handle this case, which is a slightly different problem. All right, we'll just deal with this. It's fine. Oh, wait a second. There's a simpler way to handle this. If forced not equal nil, and Knew I'd get rid of the code duplication. All right. All right. How are we doing? We're running. Not too shabby. I need some way of reporting progress now. All right. Surely there are not that many. Okay. Now I understand why the hall pass is important. Okay. All right, how do I handle this? This is actually not a contents. This is a int to express the offset in the pieces array of who's allowed to move. Okay. So we'll initialize. We have to initialize this with the hall pass holder being set to 0. brother. Okay. I think given that it's been an hour and a half now, and given that people are still, it looks, yeah, people are still struggling with part B. What I'm going to do is I'm going to finish part A tonight, and then I'm going to have to do another stream tomorrow to solve part B. I don't think it's likely that I'm going to solve part B tonight. Oh, is that it? That people did part 1 by hand and are having a time? In that case, I might be okay. I think in that case, I might have just approached this algorithmically, and that it'll serve me well in the long term. We'll see. Thank you for the hint, A9. I appreciate it. I appreciate not feeling discouraged. So I need you to find 2 functions, one for route clear and one for has reached destination. Okay. All right, how do I handle this? I heard you liked heat maps. Oh, there's nothing here. But yo, I hear you like heat maps. So I put a heat map in your heat map. Okay. Wow. Okay, yeah, that is fascinating. Okay. So if row is 0, 1, 2, 3. True. that should do it. We've pushed all the way down. Empty space below us. Keep moving. Okay. Wrong column or still in the hallway. The slot below us is full. Last one in. All right, so now, let's see this. Stuck in place in the hallway. Moved in the hallway, so lock everyone else out. Okay. 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 Now, we ask, Oh, we actually don't need to do the move down. Okay. Delta is all right. So desired column is greater than C, and delta equals 1. Is -1. Yep. Less than C. Yep. Col starts off as C. Col plus desired column. Col plus equals delta. Finally. That goes here. Okay. If W tiles are two this process twice, that'll deal with that. Okay. So I think that should do it. All right, format's okay. Let's go ahead and run it. Please don't spoil me as to what exactly part 2 is. All right. Yeah, that should do the trick. Okay. All right. Okay, so my work list is slowly declining. So I'm going to just let it run, I guess. See what happens. And I'll just keep an eye on my memory to make sure I don't my machine. But on the other hand, this one is 30 gigs. It's fine. Guessing what's happening is it's running like immensely single-threaded, and then there's another thread dedicated to doing garbage collection. I bet that's what's happening here. Okay. I'm going to try feeding it a very simplified example and make sure that it actually terminates, because if it doesn't terminate, we have a serious problem. So let's edit this, and let's just put these all into order first. So this should immediately terminate. So we're just going to check that first. Okay, yes, that immediately terminates. So now I'm going to just swap a B and an A. See what it does. It says 48 moves, or a cost of 48. Is that correct? Because that moves 1, 2. And then this one moves 1, 2 to sit here. So that's going to be 22, 23, 24, 25, 26. And then from there it would move 26, 36, 46, 56, 66. Oh, okay, so there is a faster way than that. Okay. Yeah. Okay. So I trust that maybe that one's correct. Let's try this one just for kicks and giggles. Okay, so let's feed in this one. See whether it terminates. Oh, wait. Did I do this correctly? Yeah, G-score of current plus costs index I. That's fine. Let's make sure generate moves is correct. Generate move. Yeah, because we're moving one step at a time, appending movement cost. Yeah, that seems fine. Okay. So let's continue iterating on this. On this case, let's scramble it a bit more. Okay, so that eventually returns. It just takes way longer than it should. Which makes very little sense because there's very little room to maneuver in that tiny space. Okay. Well, having seen that it's not obviously wrong, I'm tempted to just keep this running. So trying to move any A's out of a room with 2 A's in it. Oh, yeah, that's true. Yeah, let's try that scenario. Because that could result certainly in bouncing back and forth a lot. Yeah. Okay. Okay, let's try that. It's still running a while. Let's try running on this input, which now I have a bug in my code. Okay. Wait, oh, this is here. That was what was wrong. Okay, that's now reasonably speedy. But this might work now. Thank you for the hint, GM Rubrics. I appreciate it. All right. Go, go, go. Yeah, it might take a while. I'm willing to accept that. The thing I guess I can do is... can parallelize move generation. Don't really love it. Let's check check the simple case that we were given. Yep, 12,521. Okay, so now that yields the correct result. So yeah, I'm basically happy to let this run, and then I'm going to continue working on this, but I'm not like... Yeah, this... Given that I got the correct answer to the simple input really quickly, yeah, I feel pretty decent about letting this go. Oh, cool. That returned right away. That's not the correct answer. It is too high. Interesting. I guess what's happened here is this is not guaranteed here to be the we're going to handle this way. Now I understand. if G-score of current is I already know what the destination looks like, though. I just... whatever, it's fine. Okay. Okay, so now I can prune my tree once I encounter at least one winning condition. All right. Okay, now that I know that that returns relatively quickly, now that I know that my score is only too high, then I probably have a good stab at this. All right, it's churning. Has a little bit further to go because now even if it wins, it wants to check for other possible wins. But that's fine. I'm going to also set this running really quickly on my simple input just to verify that it still gets a correct answer, but it should. If it doesn't, then I know I've got another problem. Yeah, okay, that still yields 12,521. It's just searching a little bit more exhaustively. The other thing I can think of is I'm searching twice the amount of state that I have to because I'm searching based off of permutations of which thing is in which place. So if I have like AB, but I also have AB, or if I have a different AB here, like that gets treated separately. So that's my only other worry here. But I think this is solvable. The runtime is more than I would like, but it certainly is doing okay, I guess. Ideally, it would find at least one winner. I know I've just left it running for a little while, but I kind of want to go back now and have it print out every time it finds a new best score. That way I can at least verify that, you know, it's progressing. Also, in theory, the theory is that you should be able to return with A-star search. You should, in theory, be able to A-star search should, in theory, always return the lowest result. Like, it should, in theory. So that's what's really confusing about this, is I shouldn't need this lowest score thing. So I don't know what's up with this. Oh. I think I understand what I need to do here. Okay. So instead of doing this, what we're going to do... Oops. I see what we need to do. Yes, but my estimate is I think an underestimate. Right? Because this is just saying, I presume I can just, the path is clear, just let me move pieces through each other, right? So this covers the up. This covers the over. And this covers the down by at least one. I feel okay about that heuristic, but I think what's happened is... Okay. Right, what I think I need to do is just do tiles and pieces. In fact, the tiles, I'm carrying a lot of extra baggage around in memory and most of my tiles, but whatever. That shouldn't be my problem. Yeah, I think the problem is that my pieces is what's wrong. Oh, but then the hall pass. Shit. No. Okay. There is. Yeah. Therefore there is a bug here. Well, this works. Not gonna bother with truncating. Yeah, so that yields the correct number. So why? Okay, so either I have a bug in my heuristic, and likely, or yeah, that's fine. In fact, I don't need to return costs anymore. I can compute the cost automatically. Okay. So we're just going to do... Oh, no, I do need to do that. Okay. Suspect I've done wrong is I'm not allowing a movement that I should be allowing. Yeah. What have I done wrong? Oh, I see. Is it possible that someone else has the hall pass? Can we always move up if we're... Yeah, because I'm getting this on where the source is, not where the destination is. That's okay. It's fine. Yeah, I know I'm searching a much bigger space than I need to, but that should be okay. Guess there's a slightly more efficient world representation given that I'm now storing a bajillion copies of this in RAM. If I got a wrong answer, it would be a lot easier to debug, but here I'm getting the correct answers on all of the sample inputs. All right, let me quickly decrease my iteration time, because if I can't iterate quickly, then this is going to be really, really challenging. So I want to... Okay. Something like that should do the trick. OS and pprof. All right. Oh, this is runtime / pprof. Okay, now we run all right. Oh. Let's just read the, while we wait for this, let's read the code. Okay, that's helpful. Yep, spending the majority of the time in A star. Of the time spent in A star, only spending 10% of my time in move generation. Interesting. Okay, yeah. Yeah, it really is. Why is my code calling TRP? Oh, because I turned on open telemetry, right. Generating moves is 10% of my time. Pushing and popping the heap is... Oh dear god, pop is really expensive. Yeah, okay, there's not much room for me to make this more efficient. Like, a majority of this is just... Yeah, I want to understand why this is taking so long. Oh boy. Well, 800 people have solved it by now, so this is clearly a solvable problem. This is just... Okay. So let's go back and read the problem. We'll go through and read the code one more time. And if we don't succeed at... If we don't succeed at reading the code, then I might declare defeat for the night, but we'll see. 1, 10, 100. Yeah, if that were wrong, I would have the wrong answer. You'll never stop on the space immediately outside any room. So that constraint is... enforced here. Remove from the hallway to the room unless that room is your destination and that room contains no amphipods. Okay. Once it stops moving, it will stay in that spot until it can move into a room. Yeah. Okay, yeah, I think the thing that's just happening is that I'm spending way too long copying these giant freaking things around. That is unfortunate. But it still doesn't explain why I'm getting an answer that is too high. Right, how long am I spending on min cost to sort? Match no expressions. Few. Yeah, but basically it's taking no time. Interesting. All right, I'm going to commit this for now. Because that works on the sample inputs at least, which is good for something. If someone does want to take a look at it, it'll be visible here. Whoa, that was not what I meant to paste. There we go, that. And yeah, we'll see. So that does work. Just curious if I run it again, whether I'll get a different answer. So I had guessed 10,544. All right, we'll just let this run. Yeah, that was actually reasonably fast. Okay, let's profile again. Yep, okay. Like, I'm spending some time in move generation, but it's not too bad. Okay, so does this consistently take, like, 5 seconds now? Is that what's going on? Or does it sometimes take longer? Because if it takes longer, sometimes I'm going to, that's non-deterministic, which seems very sus, because this algorithm should be completely deterministic. Guess maybe map traversal order or something, I don't know. Oh, there we go, yeah, I just finished. Okay. Okay, so this does run reasonably fast. Generating moves that move through another entity in the hallway. Good question. No, I check that in my route clear. Saying my Oh, okay. I see what you mean. But I'm verifying that I'm moving it into an empty space. Does that not suffice? Because I'm already doing the A9, can you explain what you mean more? I think this check on moving up is fine. It's verifying the space is empty. that we're moving into. If an entity moves into the hallway, can only move into a space that has contiguous empty space between its burrow and its destination. This is the hallway here. I'm not sure I understand your concern, A9, because, like, that check is performed down the road. I don't think this is my problem because my answer is too high, not too low, right? If my answer is too high, that means that I'm not allowing something that I should allow. If my answer is too low, then that means I'm allowing an illegal move, right? That is my working assumption. Yes, an amphipod cannot move through the space where another is, but that is already checked by making sure that any space that I might move an amphipod into must be empty. Okay, yes. I do move one space at a time. I do move one space at a time and trust that I will prune appropriately. Okay, so is it possible that I have overestimated with my heuristic? No, I don't think so. It's in position 2. So I need to go up 1, over 1, down 1. That sign is correct there. That has literally been copy pasted. I feel relatively okay about that. Okay, I'm going to hard stop in 10 minutes if I cannot figure this out. Okay, GM Rubric says that they did a depth first search. Yeah, that's using the correct heuristic. Yep. Oh, I figured it out. This is wrong here. I'm counting myself and saying that the route is not clear. Careful reading, it's important. Yeah, I think that'll do it. That's what I meant by, like, figuring out, am I under or over counting? Knew there was something maybe sus about my route clear. Oh, wait, actually... Here. That's not quite right either. This is still here. That's a better way to phrase it. Okay. Yeah, because that would cause me to wait incorrectly for a hall pass when in fact the route is clear and I can move. No, if it was already in C, delta would be 0, but I figured that this was going to be more readable, so that's the way that I'm approaching this. Right, now we wait for the go process to run. And yeah, this would run a lot faster if I were being smart about memory and not just allocating and deallocating all over the place, but it is what it is. It's fine. Probably I should have run on the test input first, but that's okay. Oof, stringifying and parsing the world state every time. That's got to take a toll. Why am I suddenly chewing a lot more RAM and running longer? Oh, because I now am allowing a lot more possibilities. Oh, and it just finished. 10.5.26. That's correct. Yay! Insert the following lines. Oh, okay. Yes, Linux away. I am in Vancouver. Okay, so let's just profile what I just ran. And I suspect the answer is that Eric is trying to disincentivize people from doing ridiculous shit. Okay. So here's what we're going to do. What we're going to do is we're going to commit this solution first. Yeah, nice clean one-line diff there. That's hilarious. Okay, some of this code is going to need to change, some of it isn't. I don't especially love the between the first and second. Okay, so what I'm going to need to do here is I'm going to need to, for performance reasons, as the board gets bigger, I would rather not expand this. I would rather just keep track of the where all the pieces are. And I would rather I'm trying to think about doing this in a way that is map safe. Okay. At this point, I'm confident my algorithm will work. I know what I need to do to make it faster, but I've been at this for more than 2.5 hours, so I'm probably going to call the stream there, having successfully solved part A. It's not because my algorithm can't solve part B, it's because I need to optimize this code a little bit better, and in order to optimize it, I'm going to need to I'm going to need to take a little bit of time I'm going to need to be more awake to do this. Let me check off camera what my work calendar is tomorrow, because that will tell me when I can stream again. Oh, cool. I'm basically yeah, I'm basically free tomorrow at 10 a.m. So I'll probably stream 10 a.m. Tomorrow morning Pacific time, and yeah, we'll finish it here. Should be all good. Let me just jot a note to myself. Make tiles a chord terrain. This will need to be a okay. Much faster to check all 8 pieces for overlaps than to okay. So I've made a note to myself, and I will see hopefully some of you in in 10 hours. Cheers, folks.